Hi kids, Miss Block here, and today we're going to explore Earth's geologic timeline as part of our Age of the Earth unit. As always, feel free to pause and rewind or rewatch this video in its entirety in case some of the concepts or any of the concepts didn't make much sense to you the first time. While watching this video, you're going to want to make sure that you have your notes handy, right here. They should be filled out, not like mine, and your reference tables. You might even want to have it pre-turned to pages 8 and 9. You ready? Let's get started. So, as we mentioned in previous videos and in our notes, if we were to compress Earth's entire history into a 24-hour clock, humans have only been around for a couple of seconds of the last hour of that day. All right, so a couple of seconds during the last hour of the last minute of that day. So what happened in all that time prior to it? Well, let's do a real quick overview of some of the key highlighted points. So, roughly 12 to 14 billion years ago, the universe was formed in an event known as the Big Bang. During this time, all the matter and energy ever in existence was created during this explosion. We're not exactly sure what sparked it, but we know that without it, none of what we were talking about would have existed. Roughly 4.6 billion years ago, our solar system formed. So we needed to have this Big Bang explosion occur before our solar system, including our home, third rock from the sun, the Earth, present. So during 4.6 billion years ago, our sun formed, started going through nuclear fusion. All right, that's when two hydrogen atoms combine together, release energy while fusing to make helium. And we all of a sudden have a lot of dust and debris and gases coalesce and form around that sun. One of them is the Earth. 3.5 billion years ago, life appeared on our planet. Now, it wasn't like humans or anything you might be commonly thinking of when you think of life, but it was very simple, single-celled organisms. They were so simple they didn't even have a nucleus in their cell. And this is what life was like for 3 billion years. During this time, though, these organisms, they began to oxygenate the atmosphere. So let's discuss. Earth's early atmosphere and the water that was present on our planet was formed through a process called outgassing. Here, the early gases were added to Earth's atmosphere, such as water vapor, carbon dioxide, and nitrogen. This process also produced all the water that was on our surface. One of these gases you might notice is important to photosynthesis, carbon dioxide. It was through this photosynthesis of some very simple bacteria, cyanobacteria, where they were able to take the carbon dioxide and water and produce oxygen. This oxygen is important to life like us, since we need oxygen to go through respiration. 550 million years ago was the Cambrian explosion, and that's when most life formed. Now, we know this because we have evidence preserved in fossils. All right? So the fossils allow us to examine what life was like in the past. Okay? And organisms need hard body parts to be preserved. So they need to have bones, shells, exoskeletons, soft body parts. All right? They can't be preserved readily. There are exceptions, but it's very rare. So that's why we really don't know what's going on prior, really, to that 550 million years ago, because a lot of those fossils were not saved. All right? A lot of those organisms were unable to be preserved. Now, fossils show us that life evolved from simple organisms to more complex ones. So life wasn't like very complex from the get-go. We went from those very simple single-celled bacteria all the way to humans, all right? But it was a gradual changes, the accumulation of gradual changes over time. And by studying fossils, scientists have known that many organisms that existed on this planet have gone extinct, all right? And this is also supported by your reference tables, which are right here. So let's take a look. Right here you can see pages 8 and 9, the geologic history of New York State. This is key to everything that has taken place in our state, plus some major global phenomenon and events. We've organized it from going from biggest units of time to smallest. We start with eons, which is our biggest segments of time, to eras, to periods, and to epochs. You can see that most of our time is spent looking at the Phanerozoic. But the Phanerozoic is a very small component, as you see right here, so we needed to spread it out into this section right here. When you know that you're looking within the Phanerozoic, you want to use this tiny timeline here as opposed to this one. The timeline all the way on the left you would use for things that happened in the Precambrian. You're going to use this small timeline here for things that happened in the Phanerozoic. We also have a column for the life on Earth. This can be a little overwhelming over here. We also have one for the New York rock record. A lot of this here, you'll notice that there's gaps. These gaps represent unconformities or times that rocks were weathered and eroded away, or those rocks didn't form during that time. This little sliver right here can be supported by this page of your reference tables, the Generalized Bedrock Geology of New York State. You'll notice that there's certain symbols right here, and they correspond to various regions in New York State. So if you're wondering, say, which types of fossils that I would find in this location, you would have to go and see what it matches up. So like these little dots here, all right, in the Finger Lake region, they match up to right here to what I read for Devonian age bedrock. And then I can find out what was happening during the Devonian and what I would expect to find in that bedrock there. And you can also see, such as the rock over here in the Adirondacks, this is like the middle Proterozoic, and you can say how old that would form because I'm able to match this up with down here. We also have a time distribution of fossils located here, and this shows us which organisms were in existence during which periods of time. You notice at the bottom that we have various index fossils, each labeled with a specific letter, and these letters correspond to the letters on the time distribution of fossils. And this goes to support my previous statement about, going from simple to more complex. Don't forget about this column. A lot of kids never look there, but this is where we find important geologic events in New York State. So right here, all the way on the left, is life on Earth. Right here, you can find things that were not pertaining to life on this planet. It can be overwhelming at times because there's so much information, but the more that you use this chart, the more comfortable you will become with reading it. I hope that you found this review helpful. Again, you can rewatch this or any of the other videos that I posted to help you prepare in anticipation for any assessments. Take care. Goodbye.